Alright, our second example. You can see here we've got the sum to n terms for this series, 1 plus 2 squared plus 3 plus 4 squared, where n is even. Now, by looking at that series, we can see intuitively what the next few terms will be. But what we need to do with something like this is, you can see that when we look at it, we could split that into two separate series. So what we're going to do is let Sn, the sum to n terms, equal our series. Okay, and we're going to split it up now. So I'm just going to put in parentheses there our first series. So in other words, the collection of terms without the squared parts. So it'll be 1 plus 3 plus 5 and so on. Now, what's important to state here is that the number of terms as defined in the question, it says n terms, we need to split that up into the number of series. Okay, so the first half then, it's got to be half of that number, n. So it's actually, because it's even, it's just to n over 2 terms. Okay, we need to add the second series, which is 2 squared plus 4 squared plus 6 squared and so on. And similarly, it is 2 n over 2 terms. When we need to do this type of approach, what we have here, these must add up together to what's given in the question. So there's n terms in total, so we need to add, so the n over 2 and the n over 2 must add together, and they do, to n terms. Sometimes it's given a little differently, but the same rule applies. These must add up to the total number of terms given in the question. Okay, so we're going to use sigma notation to define these series. So the first one there, sum to n over 2 terms from r equals 1. What's our rule? It's 2r minus 1, because it's increasing by 2 each time, so it's 2r. So 2 1s are 2, minus 1 gives us this 1. Okay, 2 2s are 4, minus 1 gives us the 3, and so on. Okay, so that's our first series. The second series, to n over 2 equals 1, and we can see that it's going to be 2r squared, because the base here, 2, 4, 6, and so on, it increases by 2 each time, so we know it's got to be 2r, but it's the whole thing is raised to that power, so it's 2r all to the power of 2. Okay, we can simplify that, so we can break it up further again. So it's 2 at the front of our sigma of r minus equals 1 to n over 2 of 1 plus, now we can see it's 2 squared is 4, so we can put a 4 at the front, n over 2, starting from r equals 1, r squared. And what we do now, we can see, again, we've come back to these known series, r and r squared, and 1 is simple. Okay, but what do we substitute? We need to substitute n over 2 in place of what's as n in our information sheet. Okay. So, we've got 2 at the front. N over 2. N over 2 plus 1. That's all over 2. Minus, for the sigma 1 of 1, from 1 to n over 2, we have n over 2 times 1, which is just n over 2, and then 4, that's front, that's multiplied by n over 2 times n over 2 plus 1 times 2 times n over 2 plus 1, that's 6. The next step is just to simplify this algebra as far as we can. And that's what I'll do here. So for this line that I've just done here, you can see that the 2's cancel, leaving us with just n over 2 at the front of n over 2 plus 1. Still got the minus n over 2, and the 4 over 6 can simplify to 2 over 3. And the next step will be to simplify that again further. It'll be important for you to have a look at each of these lines to make sure you know how we get it. It's very easy to make simple mistakes when working through these types of problems, and you've got a fair bit of algebra to work through. That's why it really pays to be very, very good at your algebraic working. Okay, so just take care in these steps. Just make sure you can follow the lines that I'm doing. Okay, especially when it comes to the working on this line. This may not be completely obvious what's happened. Just take a look at what's being done. I could have put in some extra lines here, but I haven't. So just take care that you know how I've gotten this line here. Okay, this next line, you can see that we've just gone for a common denominator of 12 and combined that there. So I'll be looking at taking out common factor where I can and simplifying, so that I want to come eventually work through those lines so that we've got our expression in factorised form. Okay, so here's the remaining 5 lines. Just common denominator, taking out a common factor of n, expanding, collecting like terms, and then finally being able to, from that point, just factorise that quadratic so that we have our final answer in that form. Now, it's not necessarily required for you to always put it in factorised form. Have a look at what the question's asking. If it's not specifying, you could quite happily leave it in fully expanded form. Okay, so you could have it as 2n cubed plus 9n squared plus 4n all over 12. Okay, so that's the same. You could have it like that as well. But just check your question. Look at what it's asking for. Always provide your answer as the question's asking.